I think let's get started now. So welcome everyone to another JSON Ask Tom office hours. Today I have Anders here and we're gonna talk about JSON in the context of Java Spring, Spring Boot, and Spring Data. So Anders is a senior principal product manager at Oracle, and he's kind of my Java to-go person. So he's really a Java expert. And the title is quite generic here about JSON, but we're basically from the database org, and we will talk about the Oracle support of JSON and how that interacts with Spring. And with this, thanks a lot, Anders. Over to you. I will stop sharing now.
Yeah, thank you very much, Beta. And I'm going to share and, show me the code earlier. Let's click this. Oh, you didn't see anything. Yeah. So yeah, the idea of today is to talk about the different capabilities that the Oracle database has in terms of JSON, but specifically for Java developers. Now, the Java ecosystem has a wider range of options for you to create applications. And it so happens that the Spring framework and this array of different projects are one of the most popular options for creating such applications. They are not the only ones, but if you believe the service, which I'm going to show you in a moment, it will tell you that most likely, if you are working in this space, you either use a Spring or you have heard about a Spring. You might have seen it before. So yes, my name is Almiray, and even though I'm a senior principal product manager, I like to call myself a seasoned sorcerer, because I like to work with source code a lot. I do work with plenty of open source projects on my spare time, but also inside Oracle, because surprise, surprise, we do produce open source besides our commercial products. So where are we and why Spring? There is a survey, it's JetBrains, this company that creates an ID that is very popular, runs a developer survey every year. And it's not the only company that does it. But for this particular year in 2021, they interviewed close to 32,000 developers across 132 different countries. So the numbers that they have provided for this survey, which you can see via the URL at the top, and I will share the slides later, they are quite compelling, and they really paint a picture that is very close to the actual reality we live on. So one of the questions they asked them to the respondents is, what kind of approaches do you use in your system design? So it turns out that most people today are creating some sort of microservices-oriented architecture. Years ago, we used to be very much into service-oriented architecture, or just regular monoliths. But nowadays, it's like microservices, whether you're using a Spring or not, is the name of the game. Now, in terms of how do you communicate with these different microservices, these different smaller parts of your application, what kind of protocol do you use to have these different components talk to each other? Well, REST is the most common ones. Whether you are sending JSON across the wire, or is it XML, or is it some other micro format, REST continues to be the preferred choice. When they ask the question, what kind of web framework do you use? Well, the Spring dominates again. You will see the Spring Boot takes 65% of the market. And then the next one is a Spring MVC. Spring MVC stands for Module View Controller. And I believe it is a project that started somehow, I think 2003, early on in Spring Framework's life. And that's the reason why it continues to be very popular. And then you see the breakdown for the other frameworks. They really don't come very close to it. You may also be aware of Jakarta EE, previously known as Enterprise Java or Java EE. That is still a popular choice, but when you put all the numbers in the table, it's like Spring Boot continues to dominate. And when asked the question, what kind of alternative application server you use, so instead of using WebLogic or WebSphere or any other of these regular names and products for application servers. The question says, well, what do you do instead of those? And 67% of the people say, oh, we use a Spring Boot, because when you package your application, you deploy them using a Spring Boot, you typically do not need an application server. You may deploy it inside an application server if you want to, but the way that a Spring Boot application is designed and is packaged, you really don't need that. So again, Spring continues to dominate. A few words about Spring so when you understand how it came to be and what it is. So the Spring framework, the first release came out in October 1st of 2002. And if you remember the time, this is sometime in 2001, Rod Johnson, along with a few other people, created the framework as a reaction to having trouble creating enterprise Java applications with what was known at the time as enterprise Java, Java EE, or even Java 2 EE. You might, if you recall that time, that's when we had to write enterprise Java beans with the specification version 1 and version 2, and that was not a fun thing to do. It was a lot of code, it was a lot of metadata for just a tiny bit of configuration. So the idea was, let's rethink this. Let's write enterprise Java applications in a different way. And they brought in some topics that nowadays we think that have been with us forever, but back then, almost 20 years ago, they were quite new. This is known as inversional control. The idea is that instead of I, as a developer, having to create the components or the dependencies required for an object to do its job, so that I instantiate its collaborators and then inject those specifically or manually into my component, I will let some sort of environment, in this case, some sort of dependency container, to do the job for me. And this is known as dependency injection. So you simply say, I have a component ABC, and these are the relationships across ABC, given the types or the names, getters and setters, some sort of descriptor or metadata. At the time, it was done with XML. And I'll put that descriptions and the code into a container. We're not talking about Docker. This is much earlier than that. And then I will ask the container, give me an instance that contains everything that I need in order to do the job. And that's exactly what happens. Nowadays, we use annotations and some other constructs instead of XML. But pretty much everyone should know what dependency injection or have used dependency injection. At the time, Spring embraced the standards provided by Java EE, but it also provided its own APIs. They were lightweight. They were developed much faster than the standards from Java EE because there was no committee and oversight to say this is how we're going to build the platform. They just did it much, much faster. At some point, Spring grew so much in popularity that later versions of enterprise Java, like a Java, I think might have been Java EE 4 and 5 when EJB 3.0 came out to be, the types of APIs that you use for EJB 3.0 were pretty much inspired by the Spring. And after that has been a lot of cross-pollination within standard Java Enterprise and Spring. So we pass on after these years, and now we encounter another project called Spring Boot. So it's mostly 10 years after Spring Framework came out. And the Spring Boot is an opinionated way for writing applications based on the Spring Framework. The idea is that you take the power of that dependency injection container, plus conventions, plus opinionated ways to assemble components, whether you want to use annotations, whether you want to use naming conventions. And the code that you write for your application turns out to be much, much smaller, but the behavior that you get is much richer because you base your application on existing components. So you start to compose applications instead of writing things from scratch. It also popularized the single jar deployments with an embedded server. So instead of packaging your application as a WAR file and then put that and ship it into an application server, the idea is that you have a tiny web server whether it's Tomcat, Undertow, something else, which knows exactly how to bootstrap your application. So you put everything in a single jar that contains all the dependencies, you make it executable, and off you go. So that makes deployments much, much easier because there's one single unit of deployment, and you do not require any other external dependency besides a Java runtime to run this job. And almost at the same time, we got another project called Spring Data. Its first release happened, I think it's between 2012 and 2013. And the idea behind the Spring Data is that you continue to use that familiar set of APIs that you may know already from Spring. It provides a programming model for data access, which is common across disparate data sources, whether you want to use access it relational tables or relational data or non-relational data, NoSQL. So no matter what kind of data you're dealing with, the way that you will access it, the kind of APIs that you use to access it should be very similar to one another. So when the time comes that you need to switch from relational to non-relational or back, then things should be such that you have to start again from zero, from scratch, and things will come much easier. The Spring Data supports many different kind of databases, and Oracle, of course, being one of them. And this brings us into SQL versus non-SQL. So this debate that started 40 years ago, if I'm not mistaken, or so, where whether you should be using NoSQL because allegedly it's faster, because you have different kinds of APIs and query mechanisms. And there are examples where NoSQL data, like graph and spatial and JSON and column value and key value, those things actually make more sense for a particular set of use cases than relational. But it so happens that there are companies and organizations and projects and products that have this split of we can put relational data in one kind of a specialized database, and we can put graph and spatial on the others in other special databases. So now we end up with different products that need to talk to each other in some ways, whether it's at the data layer or whether it's at an application layer. And we have invented so many different projects and products to make all these things happen. And yeah, it works. And for some people, this is too much complicated. And luckily for us, we have an answer for that. This is the Converged Database from Oracle. So instead of having the different products that need to talk to each other in some way, you can have all the different formats residing in the same engine. This doesn't mean they're residing in the same instance. Of course, you can do that if you want to, but you can have it running within the same product. And now you have many, many different advantages, because the data that you query, that you store it in one format, can be queried with a different format. That's one of the things that we're going to show today. And as part of that, of the different formats that we support and the different APIs that we support, we also have recently announced the Oracle Database API for MongoDB, for which I believe you'll be much better suited to say a few words about that particular API.
Yes. Thank you. So basically, this is a service that is at the moment limited to the autonomous shared service, so autonomous JSON database or autonomous transaction processing. And what it does, it's a service that listens on the MongoDB ports. So you can connect to it with a MongoDB driver or an existing application or a new application or a tool like Compass or Mongo Shell, Mongo Import, etc. And what the service does, it interprets this wire protocol and translates it to equivalent SQL operations, basically. So at the end, you can store your MongoDB collections in a database. And because it's stored in Oracle, you can then use all the Oracle ecosystem on it. So you can do arbitrary SQL over it. So for your operational use case, you can use, for example, a Mongo application for puts and gets, finds, etc. But if you want to do reports, especially across collections, you can now use the very same data in a SQL analytical query or in a report, or you create relational views over it and you use machine learning over it, etc. And Almost done. I think the most important thing is it's not like a replication scheme. So it is not that there is like a MongoDB and we silently replicate it into an Oracle with a little delay. That's not the case. It's really that the data goes live in and out of your Oracle database. And that right now it's available in limited availability, meaning we're still adding some capabilities, doing some testing, etc. But if you create a new AJD at the moment, and you activate it for access to your IP address, you should see like a tile which shows you the MongoDB connect string, for example, and then you can immediately connect it. Yeah, thanks you, Anders.
Perfect, thank you very much for that. So with that, I'm going to switch to the demo part of the session. And so first, I'm going to make sure that I have an ATP, this particular address. I'm looking at web SQL server, SQL dev web. And I don't have any relations, not tables, nothing but servers. Right now it's plain and empty. So we're going to start small. We're going to start basic. We're going to start with just a relational table that has a JSON column. So this is kind of like a hybrid mode, whether you want to store JSON data in some relational tables. Yes, of course, we can support this. And then we're going to go next into a full JSON table, and that is not related to Mongo. And then the next version, we're going to use a Mongo API to talk to the database again. So here, let me show you. So the first thing I have here, this is your typical Spring Boot application created using the Spring initializer endpoint or web application. So the only thing that I did here, well, besides picking a nice name, I'm very good at naming, by the way, as you keep the same Spring Boot started JDBC, because we started with plain JDBC, but I add a different dependency for handling connection to the Oracle database. And the only reason I'm doing this is that by default, the managed dependencies that a Spring Boot gives you will give you access to just the Oracle driver. But what I'm doing here is configuring the JDBC 11 production POM. Now, this particular POM, if you look into it, it defines all the required dependencies that you need to talk to an autonomous database. Now, this particular dependency does not have any binaries itself. It's just another POM. For that reason, whenever you configure it if you're using Maven, then you have to specify the type POM. If you're using Gradle, there is another syntax that you need to use, but you have to also say this is something that does not provide binaries of itself. And once you do this, you refresh your project, then all the different jars that are required to talk to an autonomous database will be ready. I do have an URL that talks to my database right here configured. The application properties, the standard place where you put them. It also contains the username and the password. So for obvious reasons, I'm not going to show it, but trust me, it's there, and we'll see it when we run the demo. Another thing that I have here is because I am in charge as a developer of creating the schema. I didn't do it on the SQL console. So my application will always drop the table if it exists. So let's start with a fresh environment and then create it. So this particular DTL script is the one that does it. The application itself is a standard JDBC or a standard CLI application with a Spring. And I'm going to make use of an old friend. This is perhaps one of the earliest APIs that I started to use many years ago when I discovered Spring back in 2003. And the JDBC template is a very simple, I would say, from an outsider's point of view, API that says, you give me some SQL, and I'm going to issue a JDBC statement in many different ways, of course, and I will give you the data. And once I give you data, you have the option to map it with your own types. We're not talking about an object relational mapper. This is not Hibernate. This is not JPA. This is much simpler than that. And for mapping, I'm going to use this class. This is just a plain Java object called to do. It has just 3 properties: an ID, a name, and data. And notice that the types of the data and the name are just strings. So these should be mapped to bar charts. If I show you the schema, the data will be, or this we're assuming is going to be of type JSON. That's the only thing that we're doing here. Okay. So when we look at the code, the first thing we're going to ask the JDBC template is give me some metadata about the data source. So we know what is the product of the database. So we know we're talking to an Oracle database. We'll see that in the printout. And the information about the URL. So we know what version of that particular product, database. That's good. Perfect. We initialize the schema. So we read the schema DLL and then pass it to the database. And then we could use many different ways to seed the data into the tables. And in this way, we're doing just a batch update with just sending plain JDBC, plain SQL to the database. So in this case, we are asserting as many elements coming from this to-do list. Again, you can choose many ways to do this. I decided to use it with a simple batch update. And then, excuse me, what we're going to do is print out that particular data, right? So let's see that. Let's run this. And it just takes a moment. And there we see a Spring Boot loading. That's the particular version of the database that I'm running right now in production. It's an autonomous database, version 19C. That is the URL I'm connecting to an ATP whose name is my ATP. These are the 2 elements that were inserted. And you can see that data looks like JSON. And because it's JSON, we can change this code and do the following. So we can also print out, let's say, select from data the name, and we say to-dos equals T. And instead of doing to-do, we're just simply going to grab the first column that comes in. So you can say get a string and the first column. That's right. So this is just regular JDBC result set.
So you're looking inside the JSON, correct? So you are extracting you got the...
Right. The idea is that here we're just grabbing everything from the table as is and map it to that to-do domain object. So that's why we get the first column or the name column, ID, name, and data, and we grab it as a string. But again, it's like an opaque object from the to-do's point of view.
Mm-hmm.
Whereas in this case, we're looking into that JSON data, and we want to grab the name property of JSON. Because if we see here in the output here, there is a property called Spring, has a Boolean, and there's a property called status that has its string. So if we were to query something here, something else, we'll have to make it Spring or status. But we don't want that. We want to grab name. So when we run that, once again, we should get 2 additional rows printed out. And this case should be code and slides. Oops, that didn't work out. We got 2 nulls.
Don't you have to look for status? Like there is.
No, you're right. No, that's exactly correct. And because I explained it correctly,
you explained it correctly.
There is no name in the data. So
there could be, right? I mean, the question now would be, someone might ask, why do I get a runtime error and not a compile time error? There is no name in my data. And I think the answer to that is you don't know, right? JSON is schema flexible. Your first 2 documents did not contain a field name, but your 53rd might have it. And there is no strict schema. So like, unlike a relational schema where you know the column names and you could, I don't know, find out that there is no name column. But with JSON, that's not so easy, I guess, right? Or it's actually not a desired feature because you want to live in this schema flexible world.
Yes, exactly.
Yeah.
So of course, here I made a mistake, and we're catching it very early on. And if I had test cases, then that also would have shown it. So now we'll expect a value coming from Spring and a null value coming from the second one. So here we got the true. Yay! And of course, the second data here, this one doesn't have any Spring property, so I get a null back.
Yeah.
Now the question is, should this turn out to be an illegal argument exception, null pointer, or some sort or exception? Yes, but that is part of what you should bring in here on your application side, because what you said, Beth, is correct. This is a fluid schema, and it's not necessarily an error to ask for a property that does not exist, because I don't have any schema to validate against, right? That schema validation must happen at the application level. So with this, I know it's quite a trivial example, but it shows that you can use standard JDBC APIs or standard Spring APIs as well, because you can certainly do this with JDBC without Spring whatsoever. And in case of when you want to query the data and prepare the statements and make sure that there's no SQL injection, so you have to take care of that by yourself. JDBC template now takes care of some of those things for you, making it easier to map values that are coming back. But if you wanted to go beyond that, you don't want to write SQL by hand, there are other options that we can use. So with this, now I'm going to turn into the next example. And this example, we're going to make use of another API produced by Oracle called SODA. So the Simple Oracle Document Access API. This is yet another application that had Bootstrap with JDBC. This should be SODA demo. And I continue to use JDBC as started, so that brings all the required dependencies. Once again, I make use of the OJDBC 11 production POM file, again, type POM, to bring everything that I need to talk to an autonomous database. But I also add yet another dependency, the Oracle Java Soda dependency. Latest version is 1171. And the only reason I'm adding an exclusion here is that this particular version of the OraJ Soda dependency requires OJDBC 8 as a dependency, but my application, I would like to make use of OJDBC 11. So luckily for us, Maven has this ability to handle different variations of artifacts. You may exclude them, you may use dependency management, you may use an enforcer rules. There are many ways you can handle this. For this particular case, I definitely don't want to see this in my dependency graph. I don't need it. I already have using the 11 version. So that's the only reason why I'm using an exclusion here. The URL connection is now again in application properties. Here's the username and password, not showing it for obvious reasons. And I don't have any to-do object right now to do the mapping. This is again just a regular Spring command line application for which I'm injecting, in this case, the data source. The data source is the one that knows exactly how to connect to the database using the URL, the username, and the password. So from the data source, I grab a connection so that I can print out that metadata about my product so that I know which database I'm connecting to. And also using that connection, I make use of the SODA API. So create a client that can connect to that particular database. Right now, I'm dropping all collections to make sure that nothing is there. Create a new collection whose name is to do SODA. Insert some documents. I know it's a little bit, wonky considering the kind of trivial example that is, that just have JSON be defined directly on code. I mean, you may read it from files, it may come from many places in your real life application. In this case, it's just directly in the code. We create a document, we insert it, we display the key that has been inserted so we know, yes, it's in the database. And then we issue a query using the SODA APIs. So we're going to find elements whose name property starts with a C. And that should match this particular element, the first one that we will insert. Because the second one, the first name, the name starts with an S, not with a C. So we do that, we continue to use the SODA APIs to get a cursor, and we iterate over the cursor, and we print out the content. That's the only thing that we're doing here. Okay, so let's run that. Let's see this. And it takes just a moment for compilation to run, and we get a Spring, a starting. information in our database. Again, same production database, same URL as before. These are the two elements that we set. The key related to the first element, and then finding elements whose name start with a capital C returns a single element. And we get this. Now we can verify besides that, well, the application didn't break and it didn't turn out with an exception. If we go into SQL Server, here, the SQL dev, we get two tables. The first one was created by the JDBC example. We can tell that select start from to-dos, and we should get two elements in just a moment. I don't know why. There we go. So this is what we're looking at on the first example. So that's true, because just it's a string. Now let's look how it looks like in to-do Soda. This is the one that we created using the Soda API. Which you can see the collection adds additional columns to that particular table. Now, JSON data is opaque to the way that we're currently doing the query, but certainly we can turn this into something better, so we can inspect that. So we can say, let's look into the JSON document, and I know all the elements that I inserted should have a name property. So let's look at that. And now we're using SQL to query a JSON document. And I know this is just one single table, but if I have multiple tables, and some of them were relational, and some of them were hybrid relational and JSON, you can continue to use the same notation to query across all those different elements. And that is the beauty of the Converged Database. So far, so good. Now, you may continue to use Soda with Spring APIs. Right now, the only connection point that we have with in this example with Spring and Soda is the JDBC connection object. This is the thing that we need to pass into Soda in order to go into JSON collections. But if we added that JDBC template here, like we did in the previous example, we can reuse that data source, or we can reuse that connection to query the collection tables, but using SQL. Because again, it's just data residing in our database. But if we're going to go that way, then what about if we use the Mongo API instead of just using JSON in this way to be very explicit how the data should look like and how we're going to do these queries, trying to find a name that starts with or some other condition. What if we go the next step, which is use JSON in some predefined format, which is the way that Mongo understands this, and put that in our Oracle database. So now I have this other demo, the third demo, Spring Mongo demo. We're going to make use of a Spring data. And for that, we use yet another dependency from Spring data, Spring data Mongo. I'm also going to add the previous one, data JDBC, because besides accessing the data or storing data using the Mongo-like API, we're going to talk to it also using the plain JDBC in the same application. And then, like before, make sure that we use our JDBC 11 production to talk to our database, make sure that the dependencies are type POM, and you should be good to go, right? So this is everything that we need in order to get this simple example started. The URL to connect to the database, again, is one here, but instead of connecting, just saying the connection string and the username and password, I'm gonna have a different property, which is called a Spring Data Mongo URI that contains the full URI to connect to my database. And again, for obvious reasons, contains the username and password. I'm not going to show it, but trust me, it's there. If it wasn't there, I would not be able to connect to it. The idea behind Spring Data is that you define POJOs or entities, as known in JPA, that map from columns or the way that you define the data into the objects, the domain objects that you want to use. So again, now we have a to-do object that has 3 columns. They happen to be strings to make it easy, ID, a name, and data. And that data, even though I know that I'm dealing with MongoJSON, data again is yet another JSON document I'm going to store. So it's like a nested JSON, a structure that I'm going to put this, free from schema. And just like the first to-do we saw is plain Pojo that has getters and setters. There's nothing special about this code other than that, getters and setters. Perhaps the additional thing is this ID, which is coming from Spring Data. It will make sure that Spring Data generates a unique identifier. So I don't have to take care of sequences or auto increment or some of those. Spring Data can create the schema for me, and that's exactly what I wanted to do for me. But this object is not enough to query the data. I need a way to store it, to save it, to delete it, to query it, to do anything I want to that. So this object is an anemic domain model. It doesn't know anything about the data itself. It doesn't know anything about the data source itself. For that, I make use of another concept known as a repository. You may know this from other places as a data access object or DEO. Now, this repository class, if we were looking to go into the hierarchy, this class, Mongo repository, is the one that knows how to save, how to find or list all of them, insert, delete, or we can continue going down into the hierarchy and we'll see more capabilities. It also has this thing known as naming conventions. So if I start a method with the name find, follow it by a by, oh, that's not what I wanted to do, by, and then the name of one of those properties that I'm defining to do, which properties are defined? ID, name, and data. So I can create find by ID, find by name, find by data. I can even go and say something like find by name greater than or equal. You can see that the IDE is giving me these suggestions because there are some naming conventions that will make the code work under the covers and do the proper mapping. So these things that I'm looking here right now will be eventually turned into Mongo-like queries that will be sent to the database. So if I know the conventions, I don't have to write the queries. I just can rely on what the tool is giving me.
And can I look in what the tool is generating and then modify it? So let's say I do a find by XYZ and I want to add like some flavor to the query that the naming convention does not support. Like, is it possible to extend that, or do I have then to kind of start all over and write the query myself?
I think in that case, you will have to write the query yourself. So there are settings that you can put in application properties to do the logging of all the query statements. So you can see what kind of
okay, got it. So I could fetch it out of the log and then modify it. Got it. Yeah.
Yeah, but then you have to do, you can use any name you want to then. Mm-hmm. And then you will use another, I think it's query or native query.
Yeah.
From a Spring framework. And here you'll pass in the query that is going to be sent in directly
as a string, basically. Okay, yeah.
It's a string base, exactly. And there's a way for you to reach out to all the parameters that you're going to pass into the method that will be visible here in the query. Okay. Yes, you can do that. And the type of return also is important. So they could have done it so that I just return a single to-do object. The IDE is telling me, oh, that's fine. Or I can say, yeah, sure, return as many, because it could be the case that there are more than one element that matches that particular name.
So is there, like, let's say the list is huge. Is there also some way of, let's say, an iterator or fetch the first 100, things like this?
Yes, because Mongo repository, if you look here into the hierarchy, paging and sorting repository.
Oh, okay.
Right? So you pass an instance of a pageable object, or you can even pass an instance of sort, and that's how you define the parameters for paging and sorting.
Yeah.
Okay, so this is a DEO. This is the one that gave me access to storing, deleting, querying, everything that I want to do with the domain object. So I look into the demo application. Once again, CLI. And I'm injecting two things. The DEO even though it's just an interface, Spring will do its magic to create an instance that knows exactly what to do. And that instance will implement my interface, so I have type safety across the domain objects that I want to use. And I'm also injecting the JDBC template that we saw in the first example, so that I can query the data using plain SQL. So at the beginning of the application, once again, we see the printout of the product using JDBC because, hey, it's Oracle database, it's supposed to be relational, so why not? And then we make use of here we can see that this is the Spring Data APIs. Whoop, that is too long. We're using the DEO to delete everything in case there is something. So we start afresh. We save 2 elements. And notice that now there is no JSON, it's just the domain object. That's what we want. Mm-hmm. This looks like JSON. And then we query all of them using the final finder. So we print them out on a, again, trivial application. And we use our custom finder to find something that has a name that responds to code. And we print it out, we find it.
Aren't like the curly brackets missing there? It's braces like Spring : true in line 32. Like you said, it looks like JSON, but
it looks like JSON, but it's not, right?
Yeah.
So it should be this.
Yeah.
Well, then this should be
I'm just wondering, like, is it like a shortcut that you use there, or is
no? No, this is just a text.
Oh, okay,
but
yeah.
This is just text.
Got it. Yeah.
But you made a very, very good point, because this looks like JSON, but it's not.
Yeah.
Let's remember that.
Okay.
It's not JSON, but notice what's going to happen next. This is like embedded JSON.
Okay, interesting.
Right?
Yeah.
This is because of the example.
Mm-hmm.
And then notice what I'm going to do. I'm going to query the same data that the Mongo API has written, but I'm going to query it using plain SQL. The first query, I'm going to ask the database to grab the value from that data column as if it were JSON, and just give it back to me. Mm-hmm. The second one, I'm using at the application level, the Oracle JSON factor to read that value from a binary string and create a JSON binary object, and we'll see that. Now, if you want to do this at scale, there are other ways to make this work. It's a little bit more code that you have to use instead of the Oracle JSON factory, because here we have string instances being created that are later processed into the actual object. So this is fine for a demo purpose and for low scale of data. But if you want to go huge, there's different things that you need to do. And finally, just like we did in this first example, we use the SQL JSON capabilities. We're looking at data as if it were JSON. And remember, it looks like JSON, but it's not really JSON, right? Mm-hmm. Let's see what happens. Mm-hmm. So we'll run this. And
so this will now run both the Mongo API for the insert and then the...
Yes.
Okay, so basically you are using 2 channels here. One's the Mongo API for your inserts, I guess, correct? And some of the queries.
Yes.
And then the regular JDBC as a second connection to run SQL queries from the same program simultaneously.
Exactly. Right. So these 2 saves happen correctly. And when we do the final query, we get those 2 elements.
Yes.
Correct. And then we do find by name, find me something whose name is code. Mm-hmm. And then we get 1 element. Yes. Correct. And then we treat that data column as if it were JSON, and we print it out. Hey, look at that.
So what you had in line 32 was kind of a shortcut of JSON, where you can omit these square curly braces and these double quotes around field names, etc. So it's a shortcut, right?
Yeah. Okay. Actually, that data here, you see here, this data, this value is actually this one here. This is the one that is inside. So this is still a string. And here you can see this is the ID created by the Spring data. Yeah. And this is the kind of metadata that the Spring data requires. You know, to transform
okay, so it's a string.
free from data like this
Yeah.
into a schema. What is a schema? The to-do domain object.
Yeah. So it is not
JSON,
JSON, right? I see it there now. It's basically data : string. So this is a string. Data is a string. It's not a JSON, although it looks like a JSON. Yeah.
Looks like JSON, but it's not.
Yeah.
So the data that we're looking at here, this one, is not the one that is inside, but the one that the Spring data has added to the table. And that we can see here. We do a refresh on SQL Dev, and now we have this to do. This table has been created by Spring Data, which looks very similar to the one created by Soda. The only difference is that Spring Data says the name is going to, of the column is data. This is the JSON data.
Yeah, that's a recent change we made, exactly, yeah. So we just thought that JSON document is a bit long. So it's basically the same collection, it's just that the column name is now stored as data. It's given a different name to make it shorter.
Right. So I can use this now and say, instead of JSON document, I say data. And instead of to-do Soda, I simply say to-dos, right?
Just to-do, right? To-do with it? Yeah.
Yes. And with this, I'm going to look into the JSON data stored by Mongo.
Yeah.
And it should be code and slides. And if I say, well, you know what? Also, oh, that was wrong. Give me the data property. So that should be data.
Yeah. So now this column name and the field name are the same. So now it looks like data.data. So the first one is the column name. The second one is the field name. Yeah.
Yeah. So here we go. We query this and we get the values.
Got it. But those are strings, right? So those would be
these are plain strings
to look inside, right? So now if you say it's not really JSON, we can't do like .spring or .status, right? Because it wouldn't know that you want to look inside your string there.
Right. For that to work, we will have to translate these strings and make them proper JSON.
Yeah.
Correct.
So would Spring at this point detect that data is actually a JSON and not put it into double quotes? Because now if you would just make a JSON in here, it would still be a string that would just look like with JSON inside, right? So then there needs to be a way to tell data is actually a JSON.
Yes, correct, exactly. So there is no, right now there's no additional mapping that I can tell from here from to do, like, yes, it's a string, but also treat it as a JSON.
Right. Well, what actually, I mean, I'm very new to this, so my questions may be stupid, but what if you had like to-do had a, another, like not only had like literal or scalar values as members, but some, let's say another class or another, a reference to another class. Let's say to-dos would have a member which is XYZ, and XYZ is another class. Wouldn't it then recursively build like a nested JSON for this?
Spring Data is smart enough to figure out the relationships within the domain objects, and it will put in the right amount of metadata and references and IDs within the different instances.
Oh, okay.
Yeah. So
I'd be interested to see that maybe in a follow-up.
Yeah, this is something that you have to do by hand if you use Soda or using plain JDBC and JSON as the first example. But also with the advantages of Spring Data is that you want to use the capabilities of these DEOs that are very easy to follow, the naming conventions, but also the relationships that you may have with the different entities. Yeah. Which most of the times, the Spring Data should be able to take care of all those constraints for you.
So let's look at an example. So let's say instead of to-dos, you had a class movies, and movie had a member, which is a list of actors, and actors being objects themselves. So if you would persist that, would it like inject IDs into this, or would it kind of build like a big JSON where everything is embedded?
No, it will be two different tables. So you have two domains. There's movies and actors. There will be two tables with the same structure. So the ID, create, and the data, right? Of course. And inside that JSON is a specific information for that domain. And there should be an additional reference on ID from
Well, that
the
would be
movies
interesting
into the
to see.
application.
Yeah, let's look into that after.
Yeah,
Yeah.
but the good thing is that this demo is showing you that even though we're making use of the Spring Data to talk using the Mongo API,
Mm-hmm.
if you, like you mentioned at the beginning, if you need to read that data using relational-like queries with SQL, you can so this world gives you Mongo-like API, and the other world gives you the report-like capabilities that you know from regular SQL. Now, the advantage of the Mongo API that we have for Oracle is that this is just like any other regular Spring Data Mongo application. And the only thing that I need to do in order to have this application run correctly in Oracle is switch the URI. There's no other configuration on the Oracle.
Can you show the URI? Like, where's the URI in your code?
The URI is here, but it has my username and password.
Ah, okay, yeah, then that's not showing.
No, I'm not going to show it.
Basically, just it's the same port. It's just like a connect string that points to an Oracle Cloud instance, right?
Right, and that's exactly what I'm printing the data here. When you see connection, get metadata, get URL, and we see that it's definitely connecting to an autonomous database.
Okay, yeah.
So this is not a fake Mongo server that I'm running and saying, "Oh yeah, guys, this works." No, this is a real database. Because the data that I put in, it's right there. Yeah. Right. So you can see it here. This is the URL, but of course you don't see the username and password either. Yeah. But that is the ATP is right there. My ATP. We actually have like if you go back to the page and if you click on the left hamburger menu next to Oracle, there is the JSON page under development. So if you open this one, you would actually see these collections. Yeah, you can close this. So you see your, click on left on your to-do soda and to-do. So you see basically, it's basically a NoSQL way to access your data. So you see your collection names and you see the contents of these collections. And there where it says one at this empty object, there you can actually run these QBE queries where you have a JSON way of doing it. So you also have a JSON way to view your collections here, both your soda collections and your MongoDB collection. So you can't really tell by looking at this. The name tells you that one is a soda collection, the other is a MongoDB collection, but they're kind of working the same or at least extremely similar. Right. So the way that I created the soda collections, you see, this is just this metadata, whereas MongoDB adds a few more things in order to be able to find all the correct information. So MongoDB, that's kind of a detail, like MongoDB injects these ID values, whereas for us, these IDs are out of band. So we don't inject values into the JSON by default in Soda. It's possible to also do that, but this is if you click on to do Soda. If you look at this one, then there is an ID, but it's not part of the object. It's kind of separately. And this is if you go now back to your to the SQL stuff, just to explain some like hamburger menu again. And you go on SQL, and you now let's like left side just open one of these collections. And yeah, this is basically there is an ID column and the data in the soda collection, or in the other one. For MongoDB, the ID column and the embedded ID are the same, but then you have some additional metadata when the document was created or when it was modified, and like a hash that you can use to invalidate a cache, for example. That's called exactly. So Spring Data is adding an ID property right here, whereas for soda collections we have it outside. Exactly. Yeah. Oh, that's what actually a question I had. So you mentioned that Spring generates these IDs. How does this actually work if you have, let's say, many different threads that, like, how do they add like a GUID to it, or how do they make sure if you have many different threads that the ID? I think there are different strategies that you can set. Typical one is auto increment, and there's a single sequence across the whole database. But there are other properties that you can pass in to say, I want to use a sequence per table or sequence per entity or some other kind of a strategy. Yeah. So just showing with the defaults for this kind of demonstrations is good. But if you care about potential clashes with identifiers or you are mapping an existing data source and you're migrating into from relational to Mongo, whatever it is, and you need to make sure that those IDs are correct, then you will probably have to specify other strategies.
Yeah, or maybe even let the database, like either the Oracle or MongoDB driver, create you the ID. That's, I mean, that's what both Soda and MongoDB do, is you give it a document without the ID and it generates one, and then you just have to kind of fetch it back. But then then the problem of ID generation is not yours anymore. Then it's basically done by the database. And yeah, that should also work here with the Oracle database. Cool.
So this is what we have for you folks. There are other ways that you can talk to the database with the Spring. There are other APIs that you can use, not just the Spring Data JDBC template, but these are perhaps the most popular ones. These are the ones that most people encounter in their daily days working with a Spring.
Yeah.
And we know, of course, Spring is not the only game in town. There are other options like Micronaut Data, like Quarkus, like Hedidon, and some other things. But Spring continues again to be the dominant player.
Yeah. Where would people find more information on it? Let's say someone, I mean, we will upload the video, someone may find the recording and they may want to find out, or they may want to know now where they could find out more information on all these great things you've shown.
So what I'm going to do is post this code into a public Git repository and send the URL, and then we'll add it to the show notes so that people have access to the URL. And with some basic instructions to run it, because this is your first time encountering Spring. If not, then you should be find yourself at home very easily with this. And the slides will also be available because, well, it has a few URLs for the Spring projects, so you have not seen them before.
Yeah, okay. And I think everything you've shown you can do with an always free database. So you can sign up with Oracle Cloud, get a always free autonomous JSON database that has this MongoDB API that you can use, or you can try this out all for free. You even get, I think, 1 or 2 compute nodes in this always free tier so that you can even run your Java code there as well. Now I have one more question here. I think it's a bit related. So how would you work with your JSON itself? So you showed that JSON was being generated from POJOs, but let's say you're pulling out a JSON and it's truly schema flexible and you want to kind of modify it or analyze it. So there's things like Jackson or JSON, etc. Would you just plug these things in, or is there anything that you would recommend or that comes with Spring to work with, like navigate inside a JSON structure?
Yeah, that is a really good question. And I believe Spring doesn't provide a JSON-specific parser.
Yeah.
I mean, it simply says use what it's available to you already. Yeah. Jackson is the very popular choice and it's my personal choice. I prefer it over every other dependency. And even though I am the creator of one of the earliest JSON libraries or JSON parsers in Java, JSON lived back in 2005, my first first JSON open source project. But anyway, Jackson is much better. It's much faster. And I think that, again, that is my personal preference. Half of the people that use JSON in Java has probably come across Jackson. It's very easy to pick up.
Yeah.
And the other alternatives have similar capabilities in terms of ease of use. It depends for you if there are any benchmarks in terms of performance, or there's any specific feature that one of those alternatives provides over the others that will say, that's the one that I really need to use.
Okay, so Josh Spiegel is here. He's also, he just mentioned something I also want to mention, that we do have, so when we spoke about JSON here, then we talk about most of the time about like a text representation of your object state. So Oracle is able to store JSON as text. That is what you've shown in your example here where you use the varchar. But we also have a new data type called JSON. And that uses a binary encoding. It actually has more data types and it's faster to look inside. So now obviously you could send the database a JSON text and we will encode it, but there is also client-side direct support for that. So you could pull these OSIN bytes, this encoded JSON to the client and work with it there. And this is what Josh has put here. I can actually make Josh, let me just
yeah, that's kind of
this, and let's just make Josh a panelist, and he can actually say it himself. So where is he?
Yeah, this is part of that particular API here, which is a little bit better and faster when you go into scale, but there's even another one besides using that as bar chart column, which is, I mean, again, depending on your needs and your use case, you will switch from using one to the other.
Yeah, I think we should put like a link there as well to these JDBC extensions for OSINT type. Josh, anything else you want to add to that?
Yeah, sorry for crashing your meeting.
No, that's perfect.
You're welcome.
That's exactly what we want.
Yeah, Jackson's definitely very popular and very well used. But faster than the world's fastest JSON parser is not parsing JSON, right? And so that's what I like to recommend to people when they're working with Java is to use Oracle SQL JSON, right? Because parsing and serializing JSON text is just expensive. Even if you do it well, there's no way to get around it that it's expensive. And the facilities we provide in Oracle SQL JSON allow you to skip, work with JSON and the flexibility without actually ever materializing a JSON string. Mm-hmm. So it's, an option that if you can do it, is pretty powerful.
Well, it also gives you extended type support, isn't that correct? So in your Java application, you may have things like a timestamp or a date, etc., which are not really well represented in JSON text. So I guess with what you just said here, you could even preserve these data types, correct?
That's right. So that's the other one aspect of the binary JSON format is performance, and the other aspect is support for extended SQL types. Yeah. So you can map back and forth to Oracle relational rows to JSON back and forth without losing any fidelity in your data.
Yeah, I think this is very interesting. I think we should do a few more events for Java developers here. We're out of time. We're actually a bit over time, so I thank everyone for attending. We will upload this video to Ask Tom and YouTube. So let us know if you want to have more events on Java. I think it's a good idea. And thanks a lot, Andres.
Yeah, my pleasure, Vera. So certainly we can cover more topics related to Spring, Spring Data, or the other frameworks out there that I mentioned, Quarkus, Micronaut Data, Heliton, all those things.
Yeah, I would be very happy if we would cover them as well. Okay, thanks, Josh. Thanks, Andres. And thanks everyone for attending, and have a good rest of your day. Bye.
Bye.